In this video, we're going to be talking about associations, right? Whether or not two things have some sort of a relationship. One is connected to the other in categorical data. So go ahead, get your learning targets into your notes, press pause. Now, just as a word of caution, right? You, need to really pay attention to this. Notice that these videos require, it's required that you do more than just write what I write. Failure to truly listen, question, write down some questions to bring back to a live classroom and take diligent notes will guaranteed result in a massive failure on your part to comprehend the information, right? I'm doing the best that I can to deliver this information in a thoughtful and comprehensive manner. And I believe that this is the best way possible to give you the information. But you got to really think about it, process it, and then come back to us with questions. That is truly the process of learning. All right, let's move on. Okay, so as we begin here, we're going to look at cake or pie. The table below, said table, displays dessert preference and dominant hand, whether you're left-handed or right-handed. And so I guess what we're looking at is, do left-handers prefer cake, or do cake lovers tend to be left-handed people, or so on and so forth? What is the association here? So as we look across left to right, or as I would refer to as looking at this in terms of a row preference versus looking at this as a column preference, right? If we look at it as row preference, then we're looking at left-handed people, and out of them, 10 out of 30 prefer cake. Out of the left-handed people, 20 out of 30 prefer pie. If we were to look at just pie lovers, 20 out of 200 pie lovers happen to be left-handed. So this is going to be the trick, looking both column-wise and row-wise to the game. Stay tuned, buckle up. So for each of the calculations, describe the interpretation. So that means we're going to have to write a sentence, describe the interpretation of the percentage in terms of the situation. So really what we need to know is, what does the numerator and what does the denominator refer to? I see the 10, I see the 100. Okay, so 10 divided by 100 gives me 10%. Now this was a column, right? This is a column sort of look. So what we're going to say is the following. Out of the 100 people, so this is the denominator. The out of is always the denominator. Out of the 100 people who prefer cake. How did we know that that was prefer cake? Because we were looking at the column that prefers cake. 10% of them are left-handed. Or you could have said, they wanted the interpretation in terms of percentage. You could have said out of the 100 people, 10 of them prefer cake, but that doesn't answer it in the way that they want us to. So out of the 100 people, 10% of them are left-handed. That's the first one. Okay, for our second calculation, it says 67% from 180 out of 270. Here's my 180, here's my 270. Apparently, we are looking at this from a row formation. So we're talking about right-handed people. So I guess out of refers to my denominator. Out of 270 people, 180 of out of the 270 right-handers, 180 of them prefer pie, which apparently is 67%. So again, out of the 270 people who are right-handed, 67% of them prefer pie. Go ahead, press pause and get that into your notes. Digest it. Look at it. Do you understand it? If yes, move on to the third one. If not, rewind. Go back. Listen to this again. Now, if this makes sense to you, then number 3 should be a breeze. We're looking at 30% of something. Out of 300, where's the 300? Oh, that's the grand total. 90, what is that? Out of the 300 people, 90 of them are right-handers who prefer cake. Now, this is neither a row or a column. When I go out of the grand total, we're talking about the ands, right? Two conditions simultaneously. So 90 out of 300, or 30%, are people who prefer cake and are right-handed. So 30% of everyone, again, out of, of 270, 270 was the denominator. Of everyone was 300. That's how many people there were together. So 30% of everyone surveyed is both right-handed and prefer cake. I guess my only hesitation there was is. I believe that should be an R, but I don't know. I'll have to go to an English teacher for a debate on that one. Moving on. Now, what do we notice here? Okay. First off, the big piece is that this is in counts or frequency, right? Those are the number of times that things happen. 28, 27, 20, 25, 55 is the grand total, right? These are counts. What are we going to do? We're going to turn these into percents. There are 3 ways to do that, right? Number one, you could look at it in terms of total, grand totals, right? So overall total, and divide everything by 55. So everything would be 55, 55, 55, 55 to turn those into percents. Option number 2, we could go with row thought process, right? We could look out of healthy people, and then everything here would be divided by 25 because that's the total of that row. Then on the unhealthy row, everything would be divided by 30. Whoops. By 30 because that's the total of that row. And of course on the bottom, everything would be divided by, I'm going to scratch this out, everything would be divided by 55 because that would be that total. Okay. Now obviously that's not the case because 28 divided by 55 wouldn't give you 100%, just for the record. Now the third and final way would be to look at this in terms of column totals. And that's what we have here. And how do I know? Because everything in this column would be divided by 28. And when you take 28 in the third spot and you divide it by 28, you get, you guessed it, 100%. Now think about this. I haven't even read the paragraph yet, right? I haven't even read the paragraph, and I know that we are about to look at this in terms of columns, or right, looking vertically. Now let's go read. This two-way table, right, shows data about 55 different locations. Scientists have a list of possible chemicals that may influence the health of coral. They first look at how nitrate concentration might be related to coral health. Low nitrate, high nitrate, and whether or not the coral is healthy or unhealthy. And then we got the totals on the bottom, totals on the right, and the grand total. 55 different locations, right? And that's what this table is displaying. They want me to complete a two-way relative frequency table. So again, anytime I hear the word relative, I think percent. They want me to make a frequency table turn into a percent table for the data in the two-way table in which the relative frequencies are based on, here it comes, based on the total for each column. Okay, so that means we're going to take 20 and divide it by 28, because that's the value here, and this is the total. So this is going to be 8 divided by 28. Over on the right side, we're going to take 5, because that's the count in that box. Divided by the total in that column is 27. 22 divided by 27. And of course, 27 divided by 27 is going to equal 100%. And of course, 28 divided by 28 is going to equal 100%. So let's take a moment. You turn those into percents, and then let's move on. Press pause and do the division on your own. You need to learn how to do this on your own and to round to the nearest whole percent, properly rounding. If you don't know how to do that, you must get help. Now, again, if you haven't done this on your own, you're making failure-like choices. As I look down the column, I know that this is 71%, or at least that's what I wrote. I get 29% for the second one, and when I add these two up, it adds up to the total of 100%. If I'm looking column-wise, that's what should happen. Over here, 19 and 81 adds up to be 100%. So I'm feeling pretty good about my answers here. Okay, now let's move on. So now it says when there is a low nitrate concentration, that's this column, which has a higher relative frequency, healthy or unhealthy coral. Healthy, right? When there's low nitrate concentration, this column, which one has the higher, right? The higher, greater frequency is the healthy. Next, when there is a high nitrate concentration, is there a higher or relative frequency of healthy or unhealthy coral? So again, over on the high nitrates, looking at this column, where is the greater frequency? Higher relative frequency is here, and that's associated with unhealthy coral. High nitrate, bigger number, frequency, unhealthy coral. So not to get too ahead of ourselves, but at this point, you have to realize that, wow, there looks like there may be an association between nitrate concentration and the health of coral. Why do I say that? Because healthy coral overabundantly exists when there's a low nitrate concentration, and unhealthy coral is overabundantly existent on the high nitrate concentration. Folks, this is where the rubber meets the road. Statistics is beautiful in the fact that this is where we win court cases. This is how we can show that, hey, maybe there is a relationship between these two things. Now for D rather, what I want you to do is just kind of take what I just said and write a nice sentence here. This sentence has to be your sentence, right? You get a sentence explaining the association. And it's just along the lines of what I was saying. Hey, when this exists, versus when this other thing exists, there's a different situation. And in that sentence, you need to use the words, right? Be careful. You have to have some sort of nitrate level, right? You have to use the word nitrates. You have to use the word healthy or unhealthy coral. You got to get these words in that sentence. Is there an association? Possibly. Explain your reasoning. So I think the beginning of this is either a yes or a no. You get in there and you finish that on your own, part of your notes. Okay, now moving on, what they've done is they've given us another way to look at things. And it says that the scientists then looked at how silicon dioxide concentration might be related to coral health. The relative frequencies, again, this means percents, right? I see percents. The relative frequencies based on the total for each column. So that means we're looking vertically, right? We divided this count by the total and we got all of these percents and we got these vertical percents. Based on this table, is there a possible association? So now I'm looking at this and I'm thinking, with a low silicon dioxide, what is the most prevalent? Unhealthy, but not by much. What about in high silicon dioxide? What's the most prevalent? Unhealthy again, but again, not by much. But the bottom line is, regardless of the silicon dioxide concentration, healthy coral tends to exist somewhere between 44 to 46%. A difference of 2% really isn't too big. And on the other side, on the unhealthy, more prevalent is unhealthy, but at a difference of very little between the silicon dioxide rates, leading me to believe that there's probably little to no association. Is there a possible association? I don't really think so. Why? They want me to explain my reasoning. Because the differences between silicon dioxide concentration don't exist in healthy or unhealthy coral, right? There's really very little difference in the health with respect to the silicon dioxide concentration. Now, I've already kind of answered it in wording, but you're going to need to construct your own sentence, right? This is just a sample response, right? It doesn't have to be this way. But one of the things you want to get out is just whether or not, yes, there is, or right? So is there, right? This is a yes or no question, right? So sort of get your opinion right out of the gate, right? There does not appear to be an association. Is there an association? There does not appear to be an association, okay? Versus the other sample answer here. Hang on a second. I brought in a sample for D, right? Again, this is just a sample response. There is a possible association. So the first thing you need to answer when it asks, is there a possible association? Yes, there is. No, there's not. There seems to be. There doesn't seem to be. Get the answer out right away. Then back up your answer. For the association where you've already written this answer, right? There seems to be an association, right? There is a possible association between coral health and the level of nitrate concentration. Getting that context in there. This is because 71% of the time that nitrate concentration was low, coral reef was healthy, but the coral reef was unhealthy 19% of the time when the nitrate concentration was high. Since these values are very different, there's an association. Now, that is a textbook author version. Is that what a kid's going to write? I don't think so. I think a kid would write, there seems to be an association because overwhelmingly, when the nitrate concentration was low, the coral was healthy, and when the nitrate concentration was high, the coral was unhealthy. Something more like that. Now let's take a look at the silicon one. There does not appear to be an association between coral and health of silicon dioxide since, oh, I'm hanging on the edge of my seat now. Since what? Since the percentages for healthy in each condition are very similar, right? What condition? The low and the high silicon dioxide, right? So you don't need to talk about all four things. You could just say, hey, listen, there does not appear to be an association between what? Health and silicon dioxide concentration. Why? Because the healthy coral in each condition are very similar. Or you could have said that the unhealthy in each condition were very similar, since there's only two versions, healthy and unhealthy, right? That's the situation. Okay. So make sure that you get this down in your notes, right? You want to have this stuff written in your notes. Next, Jada surveyed 300 people, right? There's our grand total from various age groups about their shoe preference. The two-way summarizes the table, right? So let's see. Prefers sneakers without laces, sneakers with laces, prefers shoes that are not sneakers. Okay. Then we got 4 to 10 years old, 11 to 17, 18 to 24. So we have sort of like an ABC bracket here. Super young kids, middle-aged kids, older teenagers, right? And then we have three types of situations of or versions of shoes. So Jada concludes that there is a possible association between age and shoe preference. Is she right? Well, I guess we're going to have to explain our reasoning. And the first thing we need to do is decide, do we want to look at this in a row fashion or do we want to look at this in a column fashion? I got to be honest with you. If there is an association, it doesn't matter. It doesn't matter whether you go column or horizontally, but there is sort of a connection, right? And so what do you think might make sense? I think it might make sense to look at this in terms of age, right? So let's look at each age. And let's look for 4 to 10 years old. Let's look at it in a row fashion. What do they prefer? Then look at the 11 to 17-year-olds and look at how they prefer, right? So I'm going to be dividing by these totals, right? So 21 divided by 36, 12 divided by 36. Then I'm going to go down to the next bracket, right? I'm going to do 21 divided by 108 and 48 divided by 108, so on and so forth, 108. And then I'm going to go down here, right? And I'm going to divide all of these by 156 all the way across. So, and just for the record, this one up here is obviously 36 too, right? 36 all the way across. So let's go ahead, change this to relative frequencies, right? Give me some percents. Change all of those and see what's going on. And on the totals, let's go ahead and do the totals too. Let's divide 57 by 300, 144 by 300, and 129 by 300. And that's going to give us the overall of how many people overall just prefer sneakers without laces. So on and so forth. Press pause, get that worked up. So here's what I come up with. When I look at the 4 to 10-year-olds, right, 58% of them prefer sneakers without laces versus sneakers with and then not sneakers. And why might that be? Why does such an overwhelming majority of 4 to 10-year-olds prefer shoes without laces? Well, maybe some of them don't know how to tie them. And it's just easy. They're little kids. Slip on, slip off. I don't know. It's just a suggestion. I don't really know why. This is Jada's 300 people. Okay? When you go to the 11 to 17-year-olds, what happens? The preference for sneakers without laces overwhelmingly drops off. And then you see kids that prefer laces on sneakers, or they just have a larger preference for shoes that are not sneakers to begin with versus sneakers without laces. So just for the record, right? Then you get to the 18 to 24-year-olds, right? Very few of them, right? So I don't know, maybe it's not cool to have shoes that don't have sneakers. Although it reminds me of Vans skateboarding shoes, right? The skateboarders brought Vans into preference back in the day, right? Late 80s. then the majority of 18 to 24-year-olds prefer shoes that are not sneakers. Why? Getting older, a little bit more mature. Maybe they want to dress up a little more. Now, let's just look at the overall total. And then this is really the big one for me. And this is sort of getting ahead of ourselves. But if you look at this, right, 19% of, right, take age out of this, right? Forget about this. There's 57 people overall that prefer sneakers without laces. That's the total. So 57 out of the grand total, only 19% of the overall group like sneakers without laces. And when you compare that on up the board, right? The minute these don't agree with the overall, then that means there must be some sort of connection. There is an association. Just for the record, when I look, I'm going to say that again, right? When I look at this in terms of a row total, right? And I see that 58% here, 19% there, 10% there, and a 19% there. These numbers, if there was no association, should only have like around a 2% difference at best, right? X is going to be less than or equal to a plus or minus 2% difference. So, you know, these percentages here are huge. Huge. So what does our answer look like? Jada seems correct. That's where I would start. Is Jada's conclusion reasonable? Yes. Jada's conclusion is reasonable. And now we have to explain that reasoning. Youngest age group preferred, 58%, sneakers without laces, whereas the oldest group, only 10% prefer sneakers without laces. There must be an association between age and preference. Done. Get something in there for yourself. Try to come up with another reasoning. Yes, Jada's conclusion is reasonable, right? Say this again. Why? The overwhelming minority of 4 to 10-year-olds, right, are shoes that are not sneakers, whereas 11 to 17-year-old and 18 to 24-year-olds prefer more than 8%, right? Or you could say that overwhelmingly 18 to 24-year-olds overwhelmingly like shoes that are not sneakers. Overwhelmingly for young kids, sneakers without laces. Not overwhelmingly, but the majority of the middle-aged kids prefer sneakers with laces. So obviously there is an association between age and shoe preference. Now, just to have something to read and gauge, right? Don't copy this, right? You could use it for your notes, but then you should have your own interpretation of this thing, right? You should have your own interpretation, but this is just a sample response. Jade is correct. Youngest age group preferred sneakers without laces over the other two shoe options. The middle age group preferred sneakers with laces. The oldest group preferred shoes that are not sneakers. That's what I said. This is just a different version. Let's move on. Okay, so again, same game, different topics, right? We got 100 people, right? Grand total, 100 people. And we want to know, let's see, we got left-handed, right-handed, all right, pen and pencil. So again, just trying to see like who prefers pens or pencils, left-handers or right-handers. So it says, is there a possible association, right? So this is going to be a yes or no with an explanation between dominant hand and writing utensil preference. Now, are we going to look at this in terms of row or column? To be honest, unless there's an overwhelming reason to go with one, I usually just pick the first one that they mentioned and go with that row and or column. So dominant hand. So I'm just going to look at this in terms of column preference. So let's go ahead and let's divide 7 by 13. Let's divide 6 by 13. Let's divide 82 by 87. Let's divide 5 by 87. Let's turn those into percentages. Take a moment, press pause, do this on your own. Again, if you're going to wait for me to do it for you and just write down the percentages, you are going to walk away with zero increase in knowledge. You must do this by yourself. Then compare your answers to my answers. Press pause now. All right, so here we are. We notice that when we look at handedness of the left-handers, 54% prefer pen, 46% prefer pencil. Not crazy, right? It's sort of a split. But when we look at right-handers, right, overwhelmingly right-handers prefer a pen. So Is there an association between dominant hand and utensil preference? I would say that the answer here is yes, right? Left-handers sort of are split on the decision, where right-handers overwhelmingly prefer pen. And I'll get this in a little bit neater fashion, but you should try to fashion this sentence. Again, on your own, write your own sentence, right? You need to own this, right? Not just copy down my words. I want you to think about that and how you write that sentence. Your sentence should include words like left-handed, right-handed, and preference of utensil, all right? But now I just want to draw your attention to something. I did one more over here. I columned the totals, right? So 89 out of 100. So of course these are going to be the percents already, right? Because 89 over 100 is 0.89, which is 89%. So 89% of the people, of the 100 people, 89% of them prefer pen. So overwhelmingly, roughly 90% of people like pen. 94% of those people are right-handers who prefer pen. 54% are left-handed people who prefer pen. So if overall 89% prefer pen, how come that doesn't translate into the handedness, right? If there is no association, all of this top row should be the same percent. So as you're looking column-wise, the rows should match up. If you're looking row-wise, the columns should match up. If they don't, then that means somewhere there's a deviation from the overall norm, okay? So, if 75% of America likes French fries, right? And then you look into gender, right? If there's no association between gender and love of French fries, then if overall 75% of people love French fries, then there should be a 75% love of French fries amongst males and amongst females. Boom, that's it. So is there a possible association between dominant hand and writing utensil? Absolutely. Okay, I'll give you the sample version. They say that left-handed people seem pretty split evenly about pen or pencil, while right-handed overwhelmingly prefer pen. There seems to be an association. Now, of course, I like to get there seems to be an association right up front. Take that stance first and then explain why I think that way. Whoever authored this example wrote it the back end way. Now, just for the record, if you did look at preferring pen or pencil, the same situation is going to happen, but just not the exact same percents, but the same scenario. It'll show that there's an issue, right? And it'll be that among those who prefer pencil, handedness is split versus many more right-handers prefer pen than left-handers. So it's just going to be a different explanation, right? Different support for the same conclusion. No matter what, you're going to come to the conclusion that there is an association. So sort of wrapping this up, how do you know whether there is an association, right? If two variables, whether or not they're associated, right? First, you create a row or column relative frequency table. Remember, relative means percents, right? You got to translate the table into percents using conditions, either conditions on handedness or conditions on pen or pencil preference, right? Then you look for similarities in the columns of the row. If they are similar, no association. If they're different, possible association. Okay. What does it mean when we say things are associated, right? It means that they are statistically related. For example, if we compared handedness to messiness, we might find that left and right-handed people are equally messy. There would be no association. If we found out the percentage of messy was greater for right-handedness than for left-handed people, then we would have evidence of an association between handedness and messiness. That's powerful, powerful stuff in the adult world, which you will be landing in sooner than later. And let me tell you, folks, people who can explain this stuff make the most money, have the best job security. I'm not talking about college education. I'm talking about being able to articulate interesting items and connections. That's where people make money, right? So when you notice that there is an association between likes and commercials, then you try to get as many likes as you can so you can get a lot of commercials so you can make a lot of dinero. Just saying. Connectivity, connections, and identifying connections is important and powerful. So this last part you got to read on your own, right? All this stuff would be handy to read, right? And it keeps hammering this idea of association. But just for the record, what do we got? We got ice cream sales and weather conditions for 41 days. Just for the record, this is a typo. That should just be 26. 22 plus 4 is 26. So when we're looking at this data, we have 41 days at a popular creamery, and we notice that on sunny days, right, when we're looking vertically, on sunny days, what happens the most? Selling 50 or more cones. On snowy days, what happens the most? Selling fewer than 50. Well, there you go. Doesn't that make sense that they'd probably be selling lots of cones on these sunny, warm days? Just saying. Is there an association between number of cones sold and whether or not it's nice out? I would say that's a no-brainer. As you read through, and again, read on your own, but just highlighting some of the information when we look at this, right? We consider the column relative frequencies because I think it makes sense to look at temperature or type of day, right? 73% of the sunny days result in lots of cone sales. 64% of the snowy days, right? Did I say sunny the first time? Snowy days, overwhelming majority is 64% or fewer than, right? Is there an association? Of course, of course. Because these percentages are quite different, this suggests there's an association, right? A bakery might wonder, right? So now let's go to the sunny and snowy days, right? And we're looking at what? Very little differences. As remember, I said if we're looking at column percents, then the rows should match up, right? And there's very little difference here. So since the percentage with low sales are very similar, then it looks like there's not an association. But take some time, read through this on your own pace, all right? And then we'll reconvene and take a look at the cool down.